Alright, I feel obliged to start with a warning. Valve amplifiers can be dangerous to work on, even when they're unplugged because of capacitors. And this one, the Fender 300 PS, but also the 400 PS, use a B+ voltage of 700 volts. Which means if you're working on one of them and you accidentally touch the wrong thing, it will actually kill you. With that out of the way, enjoy the video. Hello ladies and gentlemen, today we're gonna have a look at this Fender 300 PS guitar amplifier. It might not look like much, but this is a really heavy boy, and if I'm to believe the label on the back, it is a 300 watts amplifier, which is absolutely insane for a Valve amplifier. 660 watts peak music power, that's kind of a bullshit figure. The actual power is 300 watts RMS, which is still a shitload of power for a Valve amplifier. And you can see the transformers are enormous. Someone's cut this grill in half, it's supposed to cover the entire back of the amplifier. And also someone's replaced one of the capacitors with this PVC pipe for whatever reason, presumably holds a smaller, more modern capacitor. And before we plug this in, we're gonna take it apart and check it out, make sure that it's not going to self-destruct. The first thing I want to do is check out the fuse. Not necessarily to see if it's good, but the value of the fuse, which is 6.3 amps. It calls for a 5 amp fuse, so we're gonna put a 5 amp fuse in there. 6.3 amps isn't that crazy, but sometimes people will put like a 20 amp fuse or a 50 amp fuse or whatever fuse in there, or wrap the fuse in tin foil because whatever. They don't have the right fuse, or the fuse keeps blowing and they want to put an end to that, but that's a horrible idea because that's how you end up burning out one of the transformers, which in this case might be entirely impossible to replace. So we don't want to take any chances with that. So anyway, let's get this thing apart. I'm gonna take the last screw out with the amplifier sitting like this because I don't want this to fall and break anything. And usually I do this with an amplifier upright, it's not a problem, but I'm not sure I can hold this because the transformer there is extremely heavy. This thing altogether is supposed to weigh about 30 kilograms. The chassis is loose in there now, but I'm not entirely sure how to proceed because this panel here is held up behind this front grille, and I have no idea how this is attached. I think it's attached with screws. So now that I have a light, I can see right there. I don't know how well it shows up on the camera. There's some Velcro that holds this front panel in place. It looks pretty fragile, it's cracked right there, so I will carefully try and remove it. That wasn't too bad. So, this is hands down the heaviest amplifier I've ever handled. It's certainly a good thing we're taking this apart, as I found this floating around under there. That's no good. Hopefully we can figure out where it comes from. Now, let's see if we can flip it. thanks to the huge transformers, it can sit nice and stable like this. Yeah, this is ridiculously heavy. So let's have a look. It's busy in there. I like it. There's this multi-band equalizer thing, which I think I will really like when this amplifier works, and all these blue things look like film capacitors, so it might be okay. We're not certain. There's electrolytics in here, however. They're really old. I have my doubts that they're any good. And indeed, someone's placed a more modern capacitor in there, and they've placed it with the legs facing, well, right now down, but normally up. Look, the kind of things you find in these things. Yes. A blob of solder stuck to the capacitor. It's probably been there since the 60s. And now it's out. Aside of a fuse of the correct value, one of the things I really insist on having is a 3-prong power cord, so we have the chassis earthed, and in this case it looks like we have that, but whenever I find one of these, a power plug that can be taken apart, besides just measuring continuity from the earth to the chassis, I also like to take it apart, because sometimes you'll find just wires flopping around in there, which would be a fun time. Looks like this one is done reasonably properly. They've thinned the wires to make them stay together. I think I'll take them out and give them crimps instead of the solder, just to have it really proper, but this is acceptable. Someone's also stuffed this in there to, I don't know, make the strain relief work with this not so properly cut cable, presumably. Anyway, we can fix that. Proper cable knife. You do like this. Now you have this properly cut off. What am I doing? I did it the wrong way around. The neutral's supposed to be on this side. It says right on there. Okay. Strain relief works just fine without this extra bit in there. In fact, I bet it works better, because those things can slide across each other. We will cut these two about like this. And leave the earth a bit long. That is important, so if something disastrous happens and this pulls out, the earth is the one that stays connected the longest. Here we have a bunch of ferrules. I think these will be the right size. Next size down. Looks far too small to ever fit. And these seem to fit just nicely. I like the square ones that are similar to this, but someone's borrowed mine. So today we're doing hexagon crimps. They're just fine also. I didn't strip this one just far enough. I've also borrowed my favorite strippers to someone. I'm regretting it dearly. I managed to destroy this end. If you end up with some short copper strands like this, it's fucked and you have to cut it off and start over. Let's try this again. All stripped. And 3 new ferrules. Okay, it took a few tries, but now we have a bootlace ferrule on each wire. And before, all 3 wires were the same length, which is not really desirable. Wait. think we're better off doing it this way, huh? That way, tightening the screw will pull the wire in rather than pushing it away. Yeah, there wasn't much wrong with this to begin with, but we made it nicer nonetheless. We can focus our attention on the actual amplifier again. The more I look at this, the more I'm thinking, what the fuck? Someone really had fun making this. They like braided these cables in a really strange way. Yeah, this. I'm gonna feel kinda sad taking this out of here, but I think it's probably gonna go. I'm not sure how it's laid out in the circuit, but I think these two capacitors are supposed to be in series or in parallel. I don't know, but I'm pretty sure they're supposed to be the same. And this is just what? There's also looks to be a component somewhere under this glue. Yeah, it's electrical tape. Yay. Disgusting. Yeah, anyway, before I'm doing too much, I'm gonna draw a schematic of this. Alright, I think I figured out the difference between the schematic we can download and the amplifier we have in front of us. This mystery circuit board gets power from right at the switch when the amplifier is on, and then the input of the amplifier goes straight to this board, and then it goes on to the preamplifier where it normally would. So what's been done is this has been cut, and then the signal goes through that board, which is pretty much the same thing like when you have an FX pedal in front of the amplifier. They just made it so that it can be in there. The reason it's behind these resistors is because that way both of the inputs work. I still don't know exactly what does it do, but I think we'll find out when we try it. And then we have the sewer pipe situation. You might already have noticed there's more than 2 wires coming out of there. If I'm not mistaken, there's 2 capacitors inside of there. Let's take a look first at the original situation, which is that we have 2 capacitors in series. They're 400 volts, but they're in series because the B plus voltage they're filtering is going to be 700 volts. And then there's 2 resistors in parallel with that to make sure that the voltage between these 2 capacitors is approximately the same. And presumably one of these capacitors went bad and it was replaced with the magical sewer pipe. And there is also 2 resistors that have been added, this one and this one, and they serve a similar purpose, keeping the voltage across these 2 capacitors approximately the same, because presumably whoever did this couldn't find the 400 volt capacitors. And we have all of that right where the original capacitor used to be. So it's also in parallel with one of these 2 15K resistors, which means the total resistance over here is going to be less than it is originally supposed to be, which means this other capacitor that's still alive is going to get a bit more voltage than it's supposed to. That's not very good, I think, so we better eventually get that out of there, and I suppose we should replace both of the capacitors. One of these 2 capacitors went bad, so I wouldn't be very surprised if this one is also near the end of its life. The markings don't say whether we need slow blow or fast blow fuses. I'm guessing we need slow blow because the fuse is before the transformer, so it has to deal with the inrush current. I have two options. I have 5 amp trage and I have mitteltrage, which is like medium slow. So we will start with the mitteltrage and see if they blow when we turn it on, but otherwise we get no excessive current draw. That means we need the slower ones. This loose screw we found, I believe, belongs in this hole, holding this tag strip, which is still solidly in place because it's also soldered. And I took out the other screw holding that tag strip, and if we compare, you can see the one at the left is the one we found loose, and the threads are all messed up. The other one not so much, and I tried it in the other screw hole and it seems the threads in there are just fine, so we just have to find a new one of these. After digging through a bunch of random screws, I found a bunch of them that have the same thread, but of course I couldn't find any that are this short, and it cannot be too long because the transformer is under here and otherwise it just bumps into that. So that's that. It's not perfect, but while I was in here I also noticed this tag strip is broken. I guess it's no big deal, but I'll note down. I should look at that later. Aren't spiders fucking weird? They like outgrow their skeleton, but it's on the outside, so they just climb out and leave it behind. And since I don't see anything that would cause this thing to self-destruct if we power it on, and by that I mean things like paper and wax capacitors, obvious signs of fire, leaking electrolytic capacitors like physically leaking or bulging, not any loose wires flopping around except this, but that's my fault. All the valves look okay. If the part that's supposed to be shiny turns white, that means the vacuum's escaped, and yeah, I don't see anything that would tell me it's definitely going to self-destruct, so we can carefully give it a try. And by carefully I mean we plug it into the isolation transformer, and this one has a knob on it, so we can turn up the voltage slowly and we can see how much current it's drawing, so that if something is dramatically wrong, we will know. Before we power it on, we're gonna measure the resistance of this and this. This is the primary of... I am wrong. We're gonna measure the resistance of this and this. That is the primary of the output transformer, and once we know the resistance of that, we can measure the voltage across it and know how much current the output valves are drawing, and that will tell us whether we need to panic and shut it off because it's gonna burn up either the valves or the output transformer, which are very expensive. The reason I was confused there for a bit is because I'm not used to seeing a transformer used for the phase inverter, which is what Fender did right here, presumably because they need a lot of power already to drive these valves. That transformer is driven by a 6v6 valve, which is already a rather powerful valve, and this is really rather unusual, and I'm curious to see how it sounds. As with any valve amplifier, it's really important we connect the load to the output before we power it on, or things can go horribly wrong. This one wants 8 ohms, and normally you'd use a speaker, but I don't want to go deaf and I don't even have a 300 watt speaker, so we're gonna use this attenuator and dummy load thing. Connect to the 8 ohms on the back here, so this will stand in for an actual speaker, but we're also gonna connect my test speaker to the output of this. We can turn the volume up with the knob then, and still hear what's going on. And then we will slowly turn up the voltage, and we're gonna keep an eye on, first of all, whether there's actually a negative bias voltage appearing over here. This is really important, because otherwise these output valves are gonna take way too much current, and related to that, we're gonna keep an eye on the voltage across the primary of the output transformer. Then we will get an actual number for the power these valves are dissipating. And we're also gonna make sure that this one capacitor doesn't see more than 400 volts because of this sewer pipe thing. This is gonna see most of the voltage, and if that's all okay, then we're also gonna check the grid of all the preamp valves to make sure that these coupling capacitors, for example, aren't going leaky. If they're going leaky, like say over here, we have probably a relatively high voltage, and then the DC is blocked by this capacitor. If that capacitor goes leaky, this grid over here is going to see a much higher voltage than the 1.6 that the schematic tells we should expect. All the same over here. If we see a higher than expected voltage over here, then we have to do something about that. That means this capacitor is probably ruined, and we have to replace it, but that's mostly a concern with the paper and wax capacitors. All of the capacitors in here except the electrolytes look like film capacitors, so with those it's not really much of a concern, but we will check to be sure. Also, normally on the input there's no coupling capacitor at all, and there's no high voltage to be blocked by it, but we have this mystery circuit board which I have not really looked at in detail, so I will check that just in case. I don't really understand why they're expecting to see 1.6 volts over here, but maybe it has something to do with just current flowing to the grid or something in this 6v6. I have no idea. But if like a normal preamp stage with a 12AX7 or 7025 like over here, you'd expect to see tens of millivolts at most. If you see several volts, that means the coupling capacitor is short. I'll also check the electrolytic capacitors with this cheap infrared thermometer if they are electrically leaky or they develop a really high ESR. Sometimes they can waste a lot of power internally and get very hot, which is bad news, and then we cancel testing until we get those replaced. Another thing I like to sanity check sometimes is when you connect a cable to the output, you can measure across the cable what resistance do you get. It should be like almost a short circuit, because sometimes these connectors will go bad, and I don't know if that's actually a concern, but I'm gonna have to wait until the neighbors are done with this sleeping thing they do at night. We are a few days later, because I got busy with other things, and I forgot to mention last time that if we see grid voltage that is too high, that doesn't necessarily mean one of the coupling capacitors went bad. It could also be something else, like the valve itself, or in this case we have this tag board, and those boards are known to go conductive over time because they absorb moisture from the air or something. So that's another thing to look out for. And I already measured the resistance of the output transformer. We can find it because it's the only transformer that hooks up to the output valves. I'm wrong. In this case it's not the only one, but it's the only extremely big one that hooks up to the output valves. And we have one wire going to the plates of this pair of valves, and then another wire going to the plates of this pair of valves, and then we have one more wire of the primary that goes to the B plus straight, and I measured the resistance between this red wire on the B plus and the blue wire for the plates of these valves, and then between the red wire also and the brown wire that goes to the other valves. We have 10 and 9 ohms, which is perfectly normal, and we'll need that number later. Also, I realized that I've never shown the other side of the amplifier. We have some ceramic disc capacitors, and these are not usually a problem unless they're in the preamp. They can be microphonic. Alright, we're all set. I have 1 meter hooked up to measure the B plus voltage, and then I have these two wired up so that they measure the voltage across the output transformer primary, so that if we divide the voltage there by 10, since we have 10 ohms on each side, we get approximately the current. If we multiply the B plus voltage by the current through the valves, and therefore the output transformer also, we will get approximately the power dissipated. These are rated 35 watts. We want about 70% of that twice, which is 50 watts. At 700 volts, that's 70 milliamps, which times 10 ohms is 0.7 volts on the meter. If it's much more than that, something's really wrong. And the rest of the things I'm not really too concerned about. I have another meter hooked up here so that we have the ground to the chassis, and then a probe on the other hand for checking other stuff. But these are the only places where something could go catastrophically wrong, I think. We have this other power valve, the 6V6, but that one is cathode biased, so if something's terribly wrong over there, I'd expect these resistors to blow up before the transformer does. And then we have a load hooked up to the output, as we should, on this thing. I also have my test speaker connected to that. And of course we're connected to the isolation transformer, and it's time to give it a little bit of voltage. I can hear some buzzing, and we're getting 9 volts of B+. That is not much. The standby switch is a bit troublesome. And now we have 277 volts. That's something. Are we getting any filaments? Nothing's wrong. 1 volt on the filament. That's at least something. Okay, we're now at 180 volts on the input. We're getting like 3 milliamps. No, 30 milliamps through the valves. Something's happening. And let's see. None of the electrolytic capacitors seem to be getting way too hot, so that's good. Now we're at like 200 volts or so, and I'm seeing 1 amp of current going in, so this beast is using 200 watts just sitting there doing nothing. Let's see if we get anything on the input. No sound. I heard hiss for a moment there, till I touched the input. Nada. No sound. I made sure the B plus is discharged just by waiting and looking at the meter. I figure maybe this mystery board is not doing us any favors, and it's really easy to do, so let's take it out of the circuit. This is temporary, don't judge. This time I connected that meter only across the one electrolytic capacitor I was worried about, the original one in there. We are now at 240 volts and apparently that's all fine. It's below 400, so we should be alright. And let's see if we get any more sound. I connected the cable now. Oh, and we do have something. Alright. It's time for this thing. Very quiet. Uh-oh. That's everything on 11. And I can hear the guitar very faintly. That's not right. Okay, here's the idea. We have a telephone with the signal generator application, giving us some sound that goes into the amplifier. We have a differential probe, so that I can measure things like 700 volts, and it's powered by a USB power bank thingy, so that it's isolated. One probe of the signal generator is connected to ground, and the other we are going to use to follow along the signal. You can see it there, the generated signal on the input. The amp's not on yet, so let's get to it. We can hear it. It sounds rather horrible. Turn the speaker down a bit. Ooh, that is not the speaker. Yikes. What is making the sound? Is it the transformer? Probably. Let's put it quieter. Okay. Is it still on at all? Yeah, it is. I can still hear it too. And right now we're not drawing that much power. The meter was packed when it was going full blast, which is about 5 amps, which should be about right for this amplifier. So, let's see anyway. Ooh, don't like that. I think it oscillates when I touch the input. Probably because we've got a rather long wire on there. Let's try the plate of the first preamp valve. Yeah, of course. We have a DC voltage on there. So I took a break, and when I came back, I turned the amplifier on and I got sound from the speaker. I ever so slightly touched this and the sound stops again. So something's wrong with the connector, and I already figured out what. If you look here, the switch in the connector is set up so that when you disconnect everything, the output is shorted, which is a far better situation than having an open circuit. And if we look how that's implemented, we have this little leaves, and there's this piece of phenolic on here which has a bump that's obviously supposed to go in that hole, so that this piece presses down when there's a connector, and it's popped out of there somehow. So I'm gonna try and put that back. I don't know if I can do that with one hand. Yes, I can. And you can see how that's supposed to work there. I'm still not sure if it disconnects properly now. It does disconnect. I can put a piece of paper in between there. my rather unscientific observation of this light. I don't think that's quite 300 watts, but I might be wrong. We will measure it later. First we're gonna take a look at the grids of all the preamp valves and stuff. I'm convinced that the power amp grids are okay. We definitely have some negative bias, or we'd get much more current through them. I know I said I'm gonna measure the negative bias voltage itself, but somehow I forgot. But the important thing is that we check if the power dissipation is okay. So we did that, and the power dissipation is actually lower than I'd expect it to be. So there's that. I think we just have to crank up the bias. So let's check grid voltages, hopefully without getting myself electrocuted. That's 0 volts right there. A bit jumpy because I feel something vibrating here, but that's just a power transformer being a power transformer. So 0 volts, maybe we should go to the millivolt scale. Yeah, so that's absolutely nothing. There's basically nothing there. That's more than 200 millivolts. Am I measuring the right spot? Oh yeah! Let's check out what happens now if I touch the input. I can hear buzzing, but it's not clear. When I first did this, I had the attenuator put the full output volume. Yeah, that gives us a nice buzz. I don't know if you can hear it. What's going on there? Ah, yeah. So the second valve is a cathode follower, so of course the grid voltage is high. And then we have what? Another cathode follower. I don't get this. You have 25 volts on the grid of what I think is V3A. No, that is V2. And we should have, according to the schematic, 750 millivolts. That's strange. And then we should have 87 volts on the cathode. That ain't right. I don't think I understand this schematic. At least not the voltages written on it. And the 6V6 is the only other one where the grid seems really important. That one has nothing at all on there, by the looks of it. Yeah. Like 1 millivolt. Also there it says 1.6 volt. So maybe that's just the bias voltage they're expecting. What I'm talking about is these voltages in the little circles. Maybe that's the voltage between the grid and cathode they're expecting. Apparently yesterday I was thinking crazy. These voltages, like 45 millivolts, don't make any sense at all as being the cathode to grid voltage. For a small preamp valve like the 7025 or a 12AU7 or a 12AX7 and those things, it's always like 1.5 or 2 volts. And for a 6V6 it would be like 15 or 20 volts. And I was staring at this, looking what could those numbers be, and it says right here, the little circle things denote the nominal 1 kHz signal for a 10 watts output. if we put the controls that way. So that means if we do what they say with the controls and we give it 1 kilohertz on the input so that we get about 10 watts at the output, we will see those signal levels at the points they're written, which allows us to verify how much the signal is being amplified, which is really useful. Basically verifies that everything else is working. We will probably go ahead and check all those levels, but before that there's some other stuff I want to check. Right now the main goal is just to establish which parts need replacing, so that when I go to order parts I only need to do that one time and pay the shipping cost one time. Since all of these film capacitors are the same type and the grid voltage over here and over here, where it's supposed to be 0 volts is actually 0 volts, I'm gonna assume that all of them are probably fine. I want to check the carbon composition resistors, because their value will go up if they get old, sometimes. If that's the case, we need to replace them. I probably have them in-house, but still. And I will also make sure that the potentiometers are okay. We need to do something about this standby switch, but I think we can take it apart and clean it. I'll also probably order a new tag strip for this. It's seen better days. So now the most exciting part of this video. We're gonna measure every single one of these carbon composition resistors. Lucky for you. I'm gonna cut most of it out, but we have the meter in resistance mode. We hook them to one resistor. I look on the schematic and check if it matches what I'd expect from looking at that. And then I move on to the next one and the next one and so on. And if something doesn't match with what I'm expecting, I will write it down and we'll see what we do about that. 15 minutes later, I only managed to find a handful of resistors that don't measure within their specification, and not all of them need replacing. For example, these screen grid resistors are all about exactly 10% high. Those are these ones, and it's not gonna affect the sound at all. It's not gonna do anything bad for the amplifier, so we might as well leave them alone. The same with this one. It reads a little bit high, but it's just for the lamp, so it doesn't matter. And there's one for the hum balance that's a bit high, and if we cannot adjust the hum balance properly, then we're gonna change that, otherwise whatever. And this one might actually matter. It's something to do with the bass and guitar equalizer thing, and it's reading 3.8 instead of 3.3, which is just over 10% high. And these might just read high because they're like in a circuit where other stuff is in parallel. I might lift one side of those resistors so that I can measure them properly. And I also found out that this foot pedal switch has a it's like a connector and there's a switch in it, and the switch is really not making proper contact, so we'll have to clean that. I might just clean all of them as a matter of course. I lifted the leg on this one and this one to measure them properly. This one's 10% out, this one's 12% out, and then the worst one here was 15% out. These are not very critical, and I doubt this one is far enough out that we'd have a noticeable result, so I think we should just leave the resistors well enough alone so that they are original. I could change my mind though, because carbon resistors can also be noisy, and if that is a problem, we have to fix it. It is time to clean some contacts, and the standby switch poses a challenge. I have this knurled ring that is as good as impossible to grab, I don't want to put pliers on there because that'd be ugly, but maybe we can manage to grab the nut on the back and give that a small turn. I have this thing. Let's find out if we can carefully get it on there. This might not be possible to get on camera. Turn the switch and it's a bit loose. Yeah, I think that did the trick. And viola. I'm surprised that we got this to work at all before. As you can see, you cannot get it to make contact much at all. And if we're really lazy, we could just flip it around and solder the other contacts on it. Those seem to be okay. Yeah, I have to be patient for the meter. Anyway, I think it's better we take it apart and clean it. Whoa. Hopefully I'll figure out how that goes together. Very smart. Yep. That is one dirty switch. It's kind of interesting. I have this little dumbbell kind of shaped thing. And I have a spring on that. And some other small bits. I have to figure this one out later. And I have a spring pushing this with the lever thingy. And this thing just rolls around in there and touches those contacts. And of course there go the screws. I'll put these aside. We have cotton on a stick, our favorite contact cleaner, and I'll put some in there and just make these cotton buds wet. I don't like spraying that stuff on things directly because it'll just go everywhere. This specific contact cleaner is to be removed after it's done its thing, and you can see this rather filthy. Come on, focus. I'm just gonna leave this for a few minutes, still wet with the cleaner, and it's gonna help it dissolve. I'm gonna worry about the little trinkets that came out of the switch, but not as important. This one is not even that dirty, and this is the only one that makes contact. The other stuff doesn't make electrical contact, but I'll clean it with some isopropyl alcohol. So I'll leave this like that for a while. Okay, I think that was long enough, and now we use this stuff to get rid of the contact cleaner and stuff. These contacts are not very well attached. I get it. There's this phenolic pieces that hold the contacts in, and when the front is not on there, they can come out. It's a bit small to show. So the way this goes together is we have this dumbbell looking thing, goes in there, rolls across the contacts. Then we have this plastic thing that holds that, and it goes like click click. There's a spring that goes in there, and then a little cup that fits on top of the spring. If that will focus. Please focus for me, baby. And then the lever of the switch has a round part that goes in there. And when I was cleaning it, I found this strange brown crud, which I think is dried up grease. So the plan is to put some of this instead of whatever that was. I'll put some in this cup and some on here. I'm gonna add a tiny bit of this. This is supposed to stop it from corroding again. I'm not sure how well this works since that switch is obviously sometimes arcing a bit. It's gonna be more than enough. That's more like it. This also feels a bit better than before. I hope the plastic can take the grease though. I'm not 100% sure, but to tighten that switch I'm using the opposite of how we got it loose, and apparently that's a valid strategy. Looks to me like I got that ring backwards though by how clean this side is. So I'm having the switch diagonal, give it a twist. Now to clean the switch part of these connectors, I'm gonna just put a cloth under there so I can actually spray them, because it seems rather troublesome otherwise. Now I'm gonna take a piece of paper, get it to the right sides. It's folded a bit to make it thick, and I'm gonna put some contact cleaner on there. And get it between there, so that we can do this. It does take something out of there, but it doesn't seem particularly dirty. I've done all of them. I also cleaned the connector part like this with the same product, and also the contacts for the connector itself, and we're gonna do the same routine, rinsing it off with this. And this shows that it was about time to clean those connectors. I have the meter connected across that connector where the switch part was giving us trouble. And now it seems to work just happily. If I touch the contact, press open, and it returns to a nice low resistance. It wasn't good the first time, I had to repeat the paper thing. And I've also checked the other ones, but those didn't have a problem to begin with. Another problem I noticed is that the lamp doesn't light up. So let's have a look. Maybe the bulb is just burnt out. That doesn't look too bad. This bulb might be original. It's General Electric, made in America. I have some probes and I cut this plastic rubbish from the connector so that they fit in my bench supply. I have 5 volts. That's supposed to be a 6.3 volt bulb. And let's find out. Let's find out if it works. It's just happy. So why didn't I see that light up? Maybe it's just this is dirty. That looks a lot better already. Ah, there we are. Yeah, I definitely would have seen that from the back, so it was actually just the bulb being dirty. I'll make sure it's really proper clean. Even normal paper is more than abrasive enough to clean something like this. I think this is actually a little blob of solder. I have removed the preamp valves so we can know what is in there, and where we should have a 7025 in the first position. We have a 1287, which is a lower gain tube. The 7027 is basically a 12AX7, but supposedly lower noise. And the second position we should have a 12AU7A, and we have what I believe is a 12AX7. I swear I've seen 12AX7 written on there, but while getting it out, I accidentally touched where the paint is, and now the paint is gone. It was very weak. And then the third position is supposed to be a 7025 again, and we have a 12AX7, which in this place would actually be a sensible substitute. The most troublesome would be this 12AU7A, which might not actually, if we put a 12AX7 in there, we might not be able to drive this rather complicated equalizer circuit, because the 12AU7 is a lower gain but also higher power valve. It seems plausible. The reason there's a 1287 in here is because we have this mystery circuit board, which I'm still assuming is a preamp. We'll try it later. Because perhaps this has a lot of gain, and having a 12AX7 right after that is just too much. Or wouldn't it be funny if someone wasn't aware that they have the wrong preamp valve and they added this to compensate? But I think it's more likely the other way around, and it's just to make this all work. So I was kind of itching to know if we can actually get 300 watts out of the amplifier as is. So the setup is as following. We have the telephone making 1 kilohertz signal. It's on full blast at the moment. And if we turn up the volume, reading the voltage across the output as a AC RMS. So if we get 300 watts on the output, we should see 49 volts there, and I'm gonna turn down the speaker all the way as not to hurt my ears. Even if we go all the way up, we get 21 volts RMS. So something is stopping us from getting full power, but I have a suspicion it's just the preamp. If I mess with the EQ, we get more. That's getting close to the 300 watts, but something sounds distorted. I'm not sure whether we're hearing the speaker or we're just hearing the transformer. So 41 volts. So yeah, this dummy load is gonna be none too happy. We can only do this for a short while. With a bit more fiddling, I managed to get the phone louder and all these adjusted, so we get the absolute maximum here, and we can get like 44 or 45 volts out of it, which equates to about 240 watts. So that's not the full 300 watts, and when I turn up the speaker it sounds distorted. We should be able to get a nice sine wave up to 300 watts. I managed to get a little bit more gain by swapping the 1287 and the 12AX7 in there. That way we get some more current to drive this tone controls, and we get more gain in the front end. So I managed to get 48 volts on there when I turn it up all the way, but of course that is running far into clipping, so I hooked up the oscilloscope so we can see when it clips. Was thinking to do this by ear, but it got annoying really quick, so I'll just look at it. Over there we start clipping. We go down a bit. We have 37, 37.8. The oscilloscope approximately agrees with that. So we get 37 volts RMS into 8 ohms. And if we do 37.8 squared divided by 8, we get 178 watts. So we're getting about half the power that we want. Maybe the problem is not the amplifier itself, because as you can see, the input voltage is dropping, and that might quite dramatically affect the output power. I'm confident enough to hook directly to the wall, and that way we get about 39 or 40 volts before clipping. I wonder if that is because the bias is rather cold, but I kind of doubt it. It could be our preamp setup. So the amplifier was off, and when I turned it on again, the light didn't come on, and I was all concerned. However, and I remembered, we used these metal Trager fuses, and I was already doubting that they could cope with the inverse current of that transformer. And since it happened when turning it on, I'm pretty sure what's happened is it couldn't cope. But I think I'm gonna put one of these in again, because we're gonna go back to the isolation transformer and variac thing anyway. And when we turn the voltage up slowly, when we power on, these are not gonna blow, but they're going to react faster if something actually were to go wrong. Okay, so to learn more, I've hooked the differential probe over here, where the 6V6 is driving the transformer that is driving the output valves, so that we can know whether the preamp stage is clipping first or the output stage. And when we turn up the volume, you can see the output stage is clipping first. So what could be wrong over here? Maybe the B plus voltage is too low, maybe the screen voltage is too low, or maybe it is the valves themselves, which would be sad, because they're really nice old General Electric valves, and they don't look like they have seen much use. You can usually tell, like, if valves have gone very hot, the silk screen will discolor. Too bad I don't have a white one to show, but also happens to them. And if you run them for many hours, regardless, like, you'll get this brown staining on the inside, which I don't know exactly where it comes from, but I've seen this on most old valves that I pulled from things, and it's unlikely, but still possible, that something's wrong with one of these transformers. This is dangerous. This time we have a meter that can actually read the B plus voltage, and the other one just starts beeping and shows overload. And it looks like it's about where it should be. We should have 700 volts and 340 volts. To actually get it here though, I had to give it a little bit more on the input. I gave it 230 until now. And at 230 we have 680 and 334. It actually asks for 250 volts, but I'm not hopeful that this is actually the issue, since that's close enough. Let's see what we get. Now we got still 37 or so volts, and the B plus does sag a little bit, but I think that's normal. Something I stupidly overlooked so far is this this potentiometer here, the output tubes matching potentiometer, which confused me to the point I recorded a whole nonsensical explanation of what I think it does, which I'm gonna spare you. But it allows you to offset the negative bias voltage between the two pairs of valves, so one can have a higher bias voltage than the other. And when I measured this, it measures a really high resistance. Well, it's supposed to be 400 ohms, that's also written on the potentiometer, so that one's dead, and that might well be all of our problems. That means if there's like measured 5k, then it measured 30k, so if there's a really high resistance between these two windings of the transformers, then we might not even have enough current to drive the control grids of these valves. Nothing to it but to take it out and see what's wrong with it. And I have these things, plastic sockets. They're really quite nice. Only I wish they made this just a hole so that you could fit long switches and a potentiometer shaft through there. Let it go. If I can, I'm replacing this with a new one, but I don't know how's my chances of finding something appropriate. This is gonna be a bitch to desolder. The difficulty is that they wrap the wires around this really good, which is good practice. But it requires some bad words to get this out, especially since it's in a really tight spot. Okay. Hey, it's free. I think the wires are still unmolten. Of course, I've been splashing solder on there. That's no good. Let's check it again to be sure. The leads are good. And there we go, totally screwed. And if this will focus, 400 ohms. So let's take this apart and see. Sometimes they're more difficult, but here these things are not pressed down that strongly. Can carefully bend them open. And I did think of something. If I really cannot find a nice replacement, we can order a normal center tapped potentiometer and just cut the shaft off and machine a slot in there. That'll work, I guess. So there's this, and then this, which doesn't look too bad. Strange. Should probably take different probes for this. Huh. So the contact between this and the rest of it is just broken. Why? It does have some corrosion even on this ring in the middle and the metal. Maybe the underside of this metal is corroded too. Since we don't have nothing to lose, I guess we'll spray this with some. I usually use this stuff, Tuner 600. The usual contact cleaner I use for other stuff is not safe for potentiometers, so this one claims to be. This dot of grease in there looks like this one has never been moved since it left the factory. Interesting. There's something on there, but I think that's just the slightest hint of carbon. Yeah, these actually look like they've been moved. Strange. Why is the grease untouched? Maybe it just moved a little bit like that and never went the other way. I guess they put the grease in there in the factory, assuming that it will spread because someone will move it. Alright, let's see if we can temporarily revive this. I really want to replace it though, because the bias voltage is gonna go through the center tap and then onto this ring and then onto the carbon track and then onto the valves. And if that connection becomes open circuit, that could be a rather nasty situation. This tuner 600 does seem to take off all the nasty stuff on here. At best, this is gonna be a temporary fix, but at least we'll get to know if there's any other problems. I managed to get it to go again. I figured YOLO and I squeezed this thing with the plier and now it works again. For how long, I don't know. So let's half-ass it back in there and see if we have any other problems to worry about. Of course. Right. Yeah. Damn it. I well and truly half-assed it back in there. This is just to try, and we'll replace this ASAP. And let's have a go. I did check the resistance of it, it's still good, and I also checked the bias potentiometer, which is the exact same type, and that one's fine. We have meters again on the primary of the output transformer, so that we can see if the valves are not dissipating too much, because we most likely have changed the bias situation. I wouldn't be surprised if this is why the bias was so cold. So we're gonna power on slowly. We go to like 200 volts and we wait a bit. It seems the bias is still nice and cold, so let's see if we get any more power out of it. Still like 38 volts before we start clipping. Well, I did notice something. This meter goes entirely crazy. This one doesn't seem to give a fuck. I don't know if that's just a meter or are we only driving one side. Now we're looking at the grid of the ones at the left there, and we are actually getting something. So we get like 28 volts RMS already on the grid, and now let's check the other grids if I can. Let's see. That's about the same, maybe a bit more. I didn't check if I could go any further there. Anyway, yeah, so I have both getting both of them have the grid driven. I cannot put that probe on the plates, otherwise the potentiometer still measures okay, and I find it really strange how little difference that made. I'd expect it to make a difference. And that leaves us with the output valves and the transformer as a suspect, which is not great news. Although the point at which the signal clipped before the grid driving transformer here wasn't too far off where the output valve started clipping, so maybe we should have a look at that again. I don't know, I'm confused at this point. I think I'm gonna go do something else and digest this. And before that, small little trivia I learned today. I've always found it odd if you measure the primary of an output transformer in an amp like this. There's always a fairly sizable imbalance. Like in this case, we had 9 ohms and 10 ohms, and you think it's the same wire and whatnot. But I read somewhere in a forum something that suddenly made me realize it's actually very sensible why this happens is because these two coils are wound around the same former and they're wound around each other. So to get them both the same inductance and whatnot, they have the same amount of windings, but because one of them is wound over the other, the one that is wound on the outside has more wire for the same amount of windings because it's doing bigger loops around. So that explains that. There is one thing I still want to try. I've always believed that the bias doesn't really have anything to do with the output power, but these valves are biased really cold. So let's try it anyway, adjust the bias and see if that makes a difference. I'd already touched that, and that's why it's a bit lower now, I think. We want to go to about 50 watts per pair of valves, which would correspond to 0.8 on these meters. Let me double check that the voltage is right. The input voltage can be a bit higher than this. Now we're at 230, so let's say 0.75, and that's the maximum this will go. Let's see if we get more output power at all. This way. Nope. This is still exactly the same. So anyway, we're gonna turn this down a little bit again, I guess. We'll put them at 0.5. It's 0.5 volts over 10 ohms. That's 50 milliamps, 25 milliamps each. 25 milliamps times 700 volts is not a whole heck of a lot. Perhaps it's worth noting that if I had a set of 6550s or KT88s, I'd just swap them in there and we would know if it's the valves or not. But I don't have any and they're really expensive valves, so that's why we're on this wild goose chase. I figured since they are telling us if we get 10 watts on the output, we should have 8.5 volt over here. We can easily verify if the gain of the output valves is okay and if the transformers are good. So let's see what we get. I've got the differential probe hooked up to the 6v6 and my normal probe to the output, and for 8 ohms we should see about 9 volts to get 10 watts. 9 squared divided by 8 is approximately 10. So the voltage over here is the output voltage, and then this is at the 6v6 where it's driving the transformer. So when we get to 9 volts approximately, this is not super accurate but should be good enough. I have 9 volts over here on the output now, and then 8 point something, approximately 8 on that 6v6 over here, which means we have more than enough gain. Also, something I did is turn the volume of this up all the way, and we have very little noise, which is nice. That's actually impressive for any amplifier, and none of the valves are microphonic, at least not the output valves. I'll have to check if the sockets are attached properly. I think they are, it's just the pins in the sockets can move a little bit, which is normal. Anyway, we learned that this transformer is okay, this transformer is okay, and these valves are at least giving us enough gain, which makes it strange that they would be weak. I cannot imagine them going weak without also losing gain. I don't know. I don't know all the failure modes of these things, but in my experience, if they get old and weak, they also lose the gain. It's been a few weeks since I worked on this, since things got in the way. I've searched for a replacement of this potentiometer that we had trouble with, and I really cannot find one for the life of me because it's a strange center tab thing. And we could use the bias potentiometer from the amp itself, which is kind of the same thing, but I'm afraid to, because I think this failed because of heat. These two contacts are where all the current goes through, and that's the ones that gave up. So I suspect because of heat and stuff, they've corroded on the underside where they connect with. Meanwhile, I found some rivets that I think should be able to replace the ones that are in here, which we're gonna cut out, and we're gonna try to repair this. Usually this wouldn't be worth doing, but this is such a hard to acquire part. And I'm afraid if I replace it with the bias potentiometer from the amp, and then I can replace the bias potentiometer with something more normal, because it only uses 2 of the contacts, it doesn't need the center tab. I'm afraid that that one will also fail in short order. Shit. I should have drilled it out further before pulling it. That was kind of stupid. at least I think the carbon track is intact. I think we can fix my idiot move. First of all, I took a smaller drill bit so we can take out the other rivets. We'll take the carbon track off and epoxy the piece of the board that broke off back on. And a smaller drill bit because I touched this a little bit and the rivet wasn't fully cut, which I thought it was, and I didn't think I was pulling it hard, but apparently this time let's pull it very gently. I'm not so sure going for a smaller drill bit was all that smart. Over here we can see the carbon track is kinda ugly. Under where that contact was. It shows up better in real than on camera. Well, damn it. And this is not my day. Third time is indeed the charm. I got one of them out without breaking anything. And I made this, which is just a piece of blank PCB material that I cut out and took the copper off with ferric chloride. So today I learned dishwashing sponges don't survive ferric chloride. And I have to get rid of this somehow. To get it roughly the right shape, we have this a fret saw with a spiral blade. I think this is for wood, but it doesn't matter. It cuts circuit boards, okay. I've put the loose pieces on some tape so I can easily check and I'm not cutting away too much if I cannot see the pencil. This took 2 saw blades because the fiberglass wears them down. And now I've put both parts together with double stick tape and I'm gonna use files to take it down to the final dimensions. I have a whole lot of very small files which work well for this. Both these diamond abrasive things and more normal files appear to work quite well for circuit boards. I forgot that I have to put something behind the board when I drill it, otherwise it will delaminate a bit like over here. Voila, it is almost good. The bad part is the holes for the rivets don't line up, and I don't really know what to do about that. They almost line up. The problem is I used a drill that is too small, so it's somewhere randomly in the holes that were in here. I thought I had the right size, but I did not. It does go together if I use my slightly too small rivets, so maybe this will work out, but I'm also not happy about how much this can move. I'm not entirely sure what I can do about it also. I think I'm just gonna put it together like it is and see how it goes. But first, the whole reason we're taking this apart is so that we can properly clean under those contacts. So let's go for it. Not only that, I also want to put some of this fader lube, and I want to make sure it gets everywhere so that we can prevent it corroding further. Because I think that's the whole problem. If no air can get in there because there's oil, or moisture for that matter, and it's not gonna corrode again. Should be good for a longer time. Now that everything is cleaned and lubricated to the best of my abilities, let's see if I can use these rivets I haven't done this before, so hoping for the best. It's on there. Would be better. Oh no, it's just not on there good. So what's happening is the rivet is expanding in the hole below it. And it's pushing the contact up. So I managed to fight the rivet out by center punching it and drilling it out. That was a bit of a nightmare, but I managed, and I figure maybe it's better if we install the rivets this way around. Because this way I can put pressure on it while I tap it down. Oh yeah, of course I'm measuring it short. 490. Bit high, but I'll take it. Hey, that worked. They're on. What a nightmare. In my head it seemed easy, but we're getting there. I've glued this thing in place so that it doesn't move anymore with a little bit of UV cure glue just on the back here, and I've given it one more droplet of that lube, and now we're ready to put it back together. Alright, it's like a new one, and we do have to double check. 490 should be about half that. That checks out. Seems good. Let's put it back about in the middle. We can install this back. And believe it or not, I do have more confidence in this than before we messed with it. I thought it's worth mentioning, I do have these rivets, and that I consider this as an option, but they're made from aluminium. And if you put aluminium and copper together, you have a rather high chance of galvanic corrosion. When the least bit of moisture gets in there, the copper will corrode much more than if the aluminium was not there. So we're using copper rivets for the copper contacts as it originally did. The potentiometer is back in there, this time not half-assed, and I'm glad to report that soldering did not melt the glue I used. And as I'm kind of losing my mind over the fact we're not getting any much power out of this, I was checking everything, also just in preparation of powering up, and I measured this connector. I measured 4 ohms, and apparently I just plugged the other end into the 4 ohm tap. I did probably unplug it at some point, and I do not know when, and yeah, it goes to show, if you think you're losing your mind, check everything. So maybe it's actually okay, maybe we are getting 300 watts, let's find out. So we have the same setup again, measuring across the output transformer, because we messed with this potentiometer, so we have to adjust it again. Let's give it some juice. And now we just want the numbers to be approximately the same. Oh yeah, I should probably turn the volume down, that's why it's so jumpy. Oh wait, the volume was down. Never mind that. About 470 each, I'm happy with that. And yeah, before I give it some signal, I'm gonna hook up the oscilloscope. Let's see how she goes. We are getting 39 volts RMS with the clipping. Let's say 37. That means we have about 170 watts, that's not 300. And I think it's the same as before, so I kind of doubt that we ever powered it up with the 4 ohm load. I might have moved that connector recently when I was cleaning up things on my bench or something. So why isn't this thing working? Why you no power? I'm kind of clueless at this point. I think I figured it out, and it's not good news. So one of our prime suspects was of course the output transformer, even though I thought it's fine. And one of the ways a transformer can fail is if there's windings in it that connect to themselves, like so that you have a loop of wire that is shorted around the core. And until recently, the only way I knew how to test for those is using a ring tester, which is something I do not have. I should build one someday, but there's apparently other ways, as I found out looking on the internet. One of the ways is using a circuit like this. We put a neon bulb and a resistor in parallel with one of the windings of the transformer, and then we send the current into it, and when we quickly disconnect the current source, we should get like a voltage spike that lights the neon bulb. However, if there's a shorted turn on there, it's gonna absorb much of the power and the bulb is not gonna flash that brightly. But there's an even easier way if you have one of these. This is an LCR meter and it's measuring the inductance of one of the windings of this small power transformer, doesn't matter which one. And now, if we take another winding of it and we short it, it's just basically equivalent of having a bunch of shorted turns. We get a lot less inductance, it's like 100 times less in this case, 1700 millihenries as opposed to 16. And this works for other windings. This is the filament. It's a lot fatter and there's a lot less turns of it. If we short that one together, we get 33 millihenries, and if we short the winding we originally had, we still get less inductance, but it's not that dramatic anymore. It's only like half. I tried this on a bunch of transformers, seems to work every time. So we hook this LCR meter to one of the primaries of the transformer, and of course, yeah, I got the thing. I disconnect the dummy load, so this end is just open circuit. We get almost 2 henries, and now if I disconnect this, the switch in that connector is gonna short it, and we get 1.9 henries, give or take, only ever so slightly more. And this, yeah, this is open circuit. So I think something is goodly wrong with that transformer. Just to make sure, it's short the connector to the chassis with this thing, and yeah, that doesn't make a difference, so the connector is shorting properly. If we press it, we get slightly more inductance. Not very stable, because my hand is not very stable, I think. This thing is kind of finicky too. Why is everything stuck? This thing is so hard to take apart. The screws are stuck. I cannot get this one out, so I took out the nut that's over here, so that we can at least get a look. This is in there. I don't know. It was like this, I believe. I think they filled this with something like tar. But paper. This looks a bit black, but I don't know if that's significant. But it does smell of fire and strangeness. And this one came out super easy. There's some paper around it, and just slide it out. This one was really trouble. It has, it seems like mysterious white powder on it. So the screws are very stuck, and I think they're stuck because of the star stuff. And I checked this stuff. It softens a small amount, but it does not melt, and it actually burns. I'm gonna double check everything, and if indeed this is definitely 100% sure the culprit, I'm gonna cut this paper open and we can have an even better look. We might try and see if we can rewind this, but that seems like a nightmare because it's like this kind of transformer where they have E-cores and well, plates in an E shape that are in opposing directions, all stuck together. So taking this apart would be a nightmare and a half. Yeah, this kind of sucks, but I'm pretty sure this is the problem. We can buy a replacement, but ouch! And since we took them out, let's admire one of these beauties. SG1885 GE, General Electric, electronic tube. Warning: pin 1 connected to base shell. Disconnect power before removing. Always a good idea. Pin 1 is not used for anything except connecting to that metal bit. And in this case it's grounded, so we don't have to worry, but oh wait, I think this is pin 1. But both of those are grounded, so in this case there's no danger, but if you see these, be aware that people might use that pin 1 since it's not connected. They might use it as a tie strip for whatever, even the B+, and yeah, that could be exciting. And this one is really nothing special, but it is made in the United States of America. So I checked again and desoldered the transformer because we have these capacitors that might mess with us, and I'd even desoldered the other side, but I put it back because apparently I'm an idiot. Look, we have the same test. This is with something plugged in, so we have open circuit on the other hand of the transformer, and we get 1.3 henries, and then we unplug it. And I checked back on the video, and yeah, I entirely missed. It was saying microhenries instead of millihenries. It boggles the mind how stupid I can be sometimes. Since we have this desoldered, let's figure out the impedance ratio of this transformer. That will further confirm that I'm an idiot and that the transformer is actually fine. I believe. So I have the signal generator connected to the secondary as well as the oscilloscope, and when we turn it on we get 1.2 volts RMS on the secondary, which we are putting in, and then if we move the oscilloscope to the primary, we're gonna get a higher voltage, and we want to know this voltage too. That's 11.8 volts. With the meter should be slightly more accurate because it has a higher input impedance, and we get 1.26 volts there and 12.1 at the primary. I did it wrong. I should measure between the two plates and not from the center tab, but that's twice as much, so 24. So we have a voltage ratio of 20 times the voltage on the primary than the secondary, and the impedance ratio is just the square of that, so that is 400. 400 times 8 ohms is 3200 ohms. That is the plate-to-plate impedance that the valves are going to see, and I have this online calculator thing open which can draw as a load line, and this allows us to enter everything for a push-pull pair. We have 4 valves, so we have to double our 3200 ohms, and I filled all the voltages correctly, and we get a load line that looks actually perfectly good. So I think it's actually a safe assumption that I was an idiot and that output transformer is just fine. The only thing I still find strange is that we only have 2 henries of inductance on the primary of this thing, while this is one side of the primary of another small output transformer, and we get 11 henries. And this time look at the units, and if we short one of the secondaries we get 8 millihenries, which is like 1000 times less. And since we're at it, I have a neon bulb here with a resistor in parallel with the primary of that small transformer just now. It's connected to my power supply, set to like 60 milliamps and 5 volts. And if we tap, you get the bulb flashing. And what if we short the secondary? It should stop flashing. At this point this is entirely redundant, I think, but what the hell? I want to know if this test is viable. This is basically doing what a ring tester does, only very crudely. But if there's not enough inductance to make a light bulb like this flash in a output transformer, I'm pretty sure that means something's goodly wrong. And we have a good connection. I can see on the power supply also when it's connected, and I have to be careful not to zap myself. No flashy flash, and now if we disconnect that secondary, we get flashing again. Nice. So it's a very neat trick to test transformers and inductance in a pinch, inductors. Then let's try it on this one. And yeah, my setup is very crappy for this, but as I said, this is redundant. I just want to know if this works, and maybe I'll make a device to do this. It's not really as good as a ring tester, because with a ring tester you can detect much more subtle issues. I imagine if there's like just one loop shorted in this transformer and not a whole bunch, it burned up in a jiffy, and we know from the smoke, since we have the impedance ratio and stuff checking out. Still, I do wonder why it smells burned. Maybe that's the tar or something. Woo! I got zapped. So yeah, that works. Yeah. The... how do you call it? The center tap of this transformer is still connected. That's why I am getting zapped through the chassis. That was intense. Yeah, so that one's good. Oh yeah! Holy shit. Still have my signal generator hooked up. Hope that one's alright. Enough with the struggle. I've never had an amplifier give me this much trouble, so I've ordered a new set of output valves, and then we will know for sure what's the problem, I hope. And while I was looking around what else to order, like capacitors and stuff, I noticed, interestingly, these white packages, they are electrolytic capacitors, 80 microfarads at 75 volts. That can only be an electrolytic, and they have polarity markings. Even we have a 3 volt electrolytic, 75 microfarads at 3 volts. Haven't seen that before, and we will not find an exact replacement, but we'll figure something out. This is just a cathode bypass, so we can just go higher capacitance and voltage. And I'm also replacing this one because it's one of those potentiometers meant for a PCB, and I don't quite like that. It feels nice when you turn it, but this is no good. The wires might fall off someday. The moment of truth has arrived in the form of these Shuguang KT8898 valves, which I was told are one of the few modern production valves that can survive the 700 volt B+ in this thing. And while I was waiting for those and a whole bunch of other parts, since this thing is only rated for 100 watts, I made this, which is a new dummy load and attenuator. It's a whole bunch of 100 watt resistors and a 150 watt potentiometer, which should survive the abuse a whole lot better. They're a bit fatter than the original ones, but they will fit just fine, and I think they look just as good. We have the same setup as a few times before. I did check with the new attenuator, and since time passed by with original valves, everything's unchanged. Let's see what gives. I want to be watching the bias closely, because these are new valves. Is it gonna settle around like 0.5? That'd be real nice. Yes, it is. Signal generator on. Let's see. It gives 35 volts. That's not... oh, but it's not really even. Ah. Shit. That's not what I want to see. And now we're without the isolation transformer, just to see if that's a factor. Nope, we're getting 39 volts, thereabouts. So, fucking hell, I can't figure it out. I don't think it's the valves, since we have a new pair and exact same shit. And I tried swapping out that 6v6, since I'm out of ideas. And that's not it either. So I noticed something rather concerning with this new set of valves. You can see there's holes in the plate, and if you look through them carefully, you can see the grids. And with this one in particular, if we give it some beans, There's one spot on one of the grids that starts glowing. I don't think that's normal. The other three don't do this, and if I move this valve around, the problem follows the valve, so I'm pretty sure it's the valve and not the amplifier. So I'll be trying to get that valve replaced. I had the valve replaced and it's just the same with the good one there. Time to do something else first, and one thing that has to be done no matter what is this front is all bent up. If you try to turn the knobs, they scrape against it. No good. I'm gonna take it off and try to fix that. You have to take all the knobs off and have a little screw. I wonder what happened actually. It's like someone tried to pull this off, but they were kinda rough with it. Hopefully we don't make it any worse. And seems like with most of these, the nut on the knob goes inside this hole, but this one we're gonna have to take off, and of course one of the knobs is being an asshole and refuses to come off. We'll have to fight with that screw. Apparently there's two of the nuts that hold this panel down, and for that I have these things, plastic sockets that you can use to unscrew these things without scratching the front panel. Rocket sockets. Pretty nice. You can get away with a metal one, I guess, if you're careful. And this one is a different size, but that makes sense because this is a potentiometer that was replaced. I almost forgot, there's two screws also that hold the panel. Now what? I think pulling on this is about the worst idea possible because it will just bend it. So I dug up this thing and we'll give that a go. Seems to work a charm. Yeah, I thought this is gonna be difficult, but it is not yet. What is difficult is filming this without getting my ass in the way. We'll fast forward. Nice and easy, it came off without any trouble, and there's a part number on there in case anyone cares. And I've read online that if you have a panel like this and it's bent, if you clamp it between some wooden planks that are straight and you leave it overnight, it will become straight. I don't get that. Why would you have to leave it overnight? Like, you know, if you bend metal, it usually happens instantaneously. But let's find out if there's anything to that. We have a nice and smooth plank. It's got like a vinyl laminate, so it will not scratch this. Put it like that. Put another board. And I'm gonna put clamps on there, going from left to right, so that... And I'm gonna put clamps on there, going from left to right. From one side to the other, because I'm concerned otherwise we'll get like this kind of a deal and force it flat, and that might not be all too good. This is all the clamps I could find so fast, and it's clamped down good. But now we take all of them off again and we see if it's straight yet. This actually already did something. It glued the panel to this. And also, it seems a bit flatter, at least the big bands that were in there. With these small things, I don't think we'll get that out. But since it's not quite flat yet, I think we should see if that guy on the forum was lying to us or not. I feel like this needs more clamps, but I don't have any. Anyway, we're leaving this for however long, and we'll see if time makes a difference. I don't believe it will, but who knows? Some guy on the forum said it does. It is 2 days later or so, and moment of truth. Well, this actually does look flatter. I'd have to check the video. I've checked the video and inconclusive. I had to use one of these again to get it off, and I'll have to work some more at these kind of things. Either way, since we got it off, we can glue it on the front properly again, so it will definitely be flatter than before. I've bent it straight by just by hand, and in part for the small bits I took a piece of wood and clamped it in a vise to press it. I got it flat enough that I think, like, if we stick it on with new glue, it's gonna be quite nice and flat. And now, after some experimentation, I figured out we can get the old glue off with some acetone and one of these things. It didn't catch me straightening this on camera because it was like impossible to film, and I didn't want to be distracted by the camera and screw up. So I put some acetone on here because I'm quite scared to get it on the front. I don't know whether it will dissolve the paint, but there's no need to find out, because we can do like this. That way there's no acetone getting on the front. And this, after doing this, you can scrape the glue off with this card, and this will continue for a while. I'm not gonna film it all. I also tried alcohol and soapy water, but neither will touch the glue. I kinda gave up on getting all the glue off. For the stubborn bits, I even got this thing out because nobody's gonna see this side anyway. And I had to bend it a little more to be what I'd consider good enough. But now it seems to fit up nicely. I think it's time to have some glue. We have this Yoo-hoo glue permanent whatever. I'd use contact cement, but I don't have any, and this is kind of the same stuff, only you have to spray it first. And I'm not gonna spray it directly onto the panel because it will drip everywhere and get on the other side and be annoying to get off. I've successfully used it like this before. We're only gonna apply it to the one side, because not just because I'm lazy. Also, if we ever want to get it off again, it's gonna be a lot easier. And the way to use this glue is we apply it and we wait until it's pretty much dry, and then we slap this thing on and press it good, and hopefully it sticks. Sometimes it doesn't, I don't know why. It's the glue feels like it is ready, and while it was setting, I got these ready in case I need to press this down in some places. And here we go. Try to get the potentiometers nicely centered. And most importantly, I need to attach this switch so that the holes in the panel and the holes in the case line up. If they don't, I'm very much screwed. And now I'll go have a coffee, take this back off and check if it's stuck down properly. No, it's not actually coffee. Alright, this worked out nicely. It's stuck down good, not gonna come off anytime soon. And it looks a lot better than before. Before, I think these knobs were scraping on the front panel. No longer the case. none of them touch. There's quite a bit of space between them and the front panel, even when they're pushed all the way down. The next thing I want to deal with are these two capacitors. They're held in with metal clamps, as you can see here, hopefully. And because one of them has been replaced by this monstrosity, they needed a smaller clamp, and it's held in with the nut and bolt over here. It's hanging on to the edge of that thing. And the replacement capacitors I got, they're slightly smaller than this one. I think they're exactly the same size as this tube. Here is a better view at the situation, and I was wondering how the hell did they manage this, because with this transformer there, we cannot get a screwdriver in there to loosen this, and even a wrench would be quite troublesome. But then I realized that I probably just screwed that clamp on before they attached those screws. So here's one of the new capacitors, significantly smaller than the original one. It's also a slightly lower capacity, 470 instead of 490, but no big difference. And the voltage rating is slightly higher. A tricky thing with these old capacitors is they say like 400 volts, but this one can actually handle 400 volts continuously, and often they don't say, but like it says maximum 450 volt surge rating, and that's more equivalent of the voltage rating on modern capacitors. This one is 550 volt, so that should be plenty. And I have new clamps for them because this wouldn't fit. I had this whole complicated plan of making a metal plate that will fit these things. I even measured a bunch of stuff, but forgot to check, and actually I can just make a new hole and use one of the existing holes and we should be good. Or we can do what they did here and not need to make holes in the chassis, but I don't know if this would be secure. But maybe we'll try this because it's kind of nice not to. So what they did here, doing it myself, I was a bit concerned that this could risk shaking loose if the thing was transported in a car or something. But I didn't tighten this at all, and it's already reasonably secure. Don't think that'd be a problem at all. And they might have been onto something. This is actually very easy, and we don't need to make extra holes. I think we'll go with that. I did one thing different. I added a washer. I have no idea if that really helps. It just seems like the nice thing to do. Gives us a little more surface area. Grabs the case. And yeah, we'll go this way. And these extra screws, they go into extra holes, not the trash. Someone someday will be thankful. Ta-da! This is wired rather confusingly. This threw me for a loop because these two resistors are in parallel with one of these, but they're on this side and they're in parallel with this resistor. And of course, the capacitor's in there. So this one, the original capacitor, goes in parallel with that. So that will be the one at this side. And then this other one has to be between the orange wire here and and this here, that's where they're connected together, the two capacitors, 3 in this case. Maybe I should cut this open and see what's inside later. What? Oops. This is what happens when you buy your pliers from AliExpress. Wonderful. So I did not manage to capture all the soldering on camera because first of all it's a bitch and my hand always gets in the way, as you can see, and the camera shut off, and I didn't notice that until after the fact. But yeah, here we are, the old capacitors are out. Now I've got to figure out how to wire the new ones in. Ideally I'd have capacitors with like a loop for wires, but I don't, because the better capacitors are this type. Couldn't find the same one with a loop. Let's see if we can capture me soldering on camera this time. I think that's good. Yeah. Oh, this is still full of the silicone stuff. I want to use the original wires where I can, so it looks alright. That gets a new capacitor soldered. So I was looking at replacing this one, and apparently I fucked up. This one, the shaft itself is the same size. The threaded part is way too big. It's gonna be loose in there. Also, this thing is in the way, but that's an easy fix, I guess. At the risk of breaking another pair of pliers. Oops. If I can find some tube or something that I can stop it from going back and forth, this might still work, but we'll see about that later. I think you can see why I'm concerned about this. It's just the slightest bit of wire soldered on there. Of course, one thing we could do is just desolder that, wrap the wire around it and call it a day. Now something I've been wanting to try from the start. This one's supposed to be 12AU7 or ECC 802, and it has been this 1287 because that's what was in there, and I didn't have one, didn't have the correct valve, So let's try that now. I just tested it again after we replaced the capacitors just to make sure that I did everything right, and it's still behaving the same, which I'd expect. The reason to replace this is just that it would remain okay for some years to come, because I don't particularly trust that capacitor, and I most definitely don't trust this thing. So with the correct valve in there, the 12AU7, we get still only 38 or so volts on the output until we start clipping. It's like just under 200 watts. Of course, if we go full blast, we can get like 44 volts RMS out of there, which maybe Fender is like stretching the truth and calling it 300 watts because of that. I'm really still stumped why we're not getting the advertised amount of power. And I've decided I'm gonna try using this potentiometer, but solder it in a way that I feel confident it won't shake loose. And I don't think I'm gonna film all my soldering anymore, because it's probably kind of boring to watch. This video is getting very long, and you kind of know how it goes. I might film some things here and there if it seems interesting. Yeah, maybe I can show what I'm concerned about. Look, yeah, that's not really what you want. It has to be a little bit more robust than that, even though nobody's gonna pull the wire. This thing might be moved in a car, something like that, and there's a lot of shaking, and those things will come loose. I've seen that happen. Now every pin has the wires wrapped around it. That should be a lot more robust than it was before, and it's also easier to solder that way, so I don't understand why it was done the way it was. Maybe someone didn't have their thinking cap on, they were just starting out. Here we go. I think that should be more than good enough. It feels a bit different than the other knobs, but it seems kind of silly to order a potentiometer by itself for this. They don't cost a lot, but if we have to count in shipping costs, that would be a stupid expensive potentiometer if that's the only thing we're ordering. I have this thing to replace this one, which has broken, but unlike the old one, it's meant to sit very close to the chassis, which I'm not sure how I feel about that. I think I might try and bend it a bit so that it also sits at the distance, because there's gonna be 700 volts on there, which is quite a lot. And again, the distance here is also not that much, and it's fine, but this is even less distance. Yeah, that wouldn't be good if the case gets live at 700 volts. I've bent it a little bit, I added some washers, and now I'd say there's plenty of clearance. It's not as much as the original one, but there's no less clearance than there's over here, so electrically it shouldn't make a difference. The desoldering iron really helps with getting these loose, because the wire is like wrapped around those terminals, and if we just use a soldering iron, it really doesn't easily want to come off. But if we suck most of the solder off of here, it'll come without much problem. Voila, like nothing ever happened, and this one is what it used to look like, but of course it was broken on that side. Alright, I got tired of filming. I'm replacing the capacitors, and look at this. These are the replacements and these are the originals, and aren't they a beautiful match? I tried to get the best quality capacitors I can get. these spray are really good. These ones I don't really know, but I trust them better than the old ones because electrolytic capacitors, they have liquid in them and they wear out eventually, at least that's what I believe. And another thing I thought worth showing is how much smaller this one is. This is a 16 microfarad 400 something volts and this one is 2. It's a lot smaller. Well, these ones, they're about the same size like the originals. I have them somewhere here. Yeah, these are the originals. They're about the same size. I'm keeping all these, by the way, in case someone really cares about originality. You could always put them back. I don't cut the leads. I carefully bend them out while I'm desoldering them. Something funny I noticed as I'm replacing the capacitors is that this one is 25 microfarads and 25 volts, and so is this one that came from this board, and they're entirely different. So I suspect one of them was replaced in the past, or Fender is really doing a weird, and I'm struggling a bit with this one because the leads are going through these loops and then they're wrapped around twice. I'm kind of breaking the rules. I'm going down in voltage rating with this one. I'm going for 475 volts instead of 500, and because I couldn't find a 16 UF 500 volt capacitor. Anyway, I've double checked and triple checked and this doesn't see anywhere near that voltage, so it should be alright. I took this panel off again because my glue was coming loose on one side. Obviously it wasn't strong enough, so now I bought proper contact cement and I bought glue remover and I bought this stuff, which is a thinner and degreaser, which seems to work better as a glue remover too. I tried it on some test pieces with this stuff. I also tried the spray glue that I originally used and this works a lot better. Also there's a solvent-free version of many contact cements, and apparently the solvent-free stuff works alright, but not on metal or glass or anything that's not porous, so this is the stuff to use. Another thing to do is look at this front panel. It has been cracked. I'm kind of seeing a pattern that everything on the front got fucked. So I suppose this thing fell on its face at some point in its history. I have this plastic surround. I've searched high and low for something the same size. But so far no luck. And it's also detaching. I'll have to figure out how to glue this. This plastic was already loose and it's also damaged. I've looked high and low for a replacement, like the same type of plastic channel, but I cannot find anything. I find a lot of this type of stuff, but nothing quite the right size. The obvious thing to do would be get a new piece of fiberboard, but this textile, which is the only thing I think holds it together still, is stretched on the front of that, and I don't really like my chances of taking this off and stretching it over a new piece of wood, because it's already been trimmed, and the way you normally do this is you have some extra so you can pull on it while you staple it. So I guess I'm gonna start by taking off this plastic and then I'll take a look. Maybe if we get some glue in between there and clamp it, could be strong. Otherwise I have to put something on the back of this. I do think we have some space to work with. Still stapled on one end. I wonder if this is factory. The staples look kinda crude to be from the factory, so maybe someone's had a go at this before. So these velcros are glued on there and kinda crudely stapled. This plastic really isn't in very good shape. It fell apart. Well, I took it off, and I'm quite surprised how much it did for keeping this rigid. It's a lot more floppy now that the plastic is off. I suppose that is why it's broken this way. Also, I'm a daddy now. I have planned. I've decided what I want to try first is getting some glue in that crack, and for that I have this syringe. It's got a proper lawyer lock, so the glue cannot push this syringe off unexpectedly and spray glue everywhere. And I've got a pretty thick needle on there with a blunt point so I don't stab myself. And we'll be using PVA glue because that works pretty well on wood and it dries transparent, so if some of it comes through to the other side it's not gonna be visible. So let's see how this goes. This is not something I've tried before. Also, I am by no means a woodworker, so take this for what it's worth. It does seem possible to get glue in here. It's a good start. And as the syringe says, this thing will be for single use only. This is gonna be glued shut. It's bad enough getting this bottle open. Was also glued shut. Had to get the big pliers out to get that. Let's see how we go. It actually seems to be going well. I only realized quite late. I probably don't need that much because it's gonna squeeze out anyway. Yeah, a bit too much of this doesn't hurt. It easily comes off. And I have to find something heavy to put on this. So it's held nicely together while drying. Alright. I think that will be about enough. Yeah. Let's get some weight on there. Yeah. I don't think batteries are heavy enough. It shouldn't be too heavy, just has to hold this approximately flat. And to save myself some work later, yeah, this looks ugly, but I don't think that's gonna be visible later. I think this is actually enough weight. I don't know if this is better to press it like this so it can get closed up all the way, or we should just try to clamp it straight, but we're going with this. I think it's actually okay if it's a little bit pulling that way because the cloth is pulling the other way. Ah, here, that's more weight. Alright, now we wait a couple hours. I felt like it needed more weight, so I added that. And the thought of diluting the glue crossed my head, but I'm too concerned it would mess up the front if I did that, because it would run through all the way. It is the next day and this is looking good and it feels really solid too. So the next thing to deal with is this sad looking plastic trim. I don't think it's worth gluing and I cannot really find any proper replacement that doesn't cost an arm and a leg. However, I was able to find this, which is almost the right size. It's too small. And I had a go at softening it with hot air and getting it the right shape around a piece of wood that's about the right thickness. And this is my first attempt, which is half successful. And after a few tries, we got this, which looks pretty good. Ignore the end, because it's the end where I started. We can cut that off if we do a long piece. And I even made a little corner in it, which looks about good enough. I'll try to do a better job on the final piece. So let's have a go at this. Cheap heat gun and some pieces of wood. That's all it takes. Now we have something to push against. I think it's gonna be easier. I tried this one too, it's no good. I think the winning strategy is just heat it up and press it between these blocks, wait, repeat. So let's find out. I have to be a bit more careful not to deform the underside. Hopefully we get enough out of this. Have another one of these if I fail. This turns out to be a lot more difficult than I expected from how well the small test piece turns out. I might do good just buying an L-shaped PVC instead, since how flat I managed to get this corner really determines how straight this edge is coming out, and it's just a struggle. Apparently I've made a mistake. This one I replaced with a 220, used to be a 150 UF, but I didn't find the right one in the box that I had, but apparently I have this on my floor. I did order the correct replacement, 150 UF at 10 volts, so I'll swap that out. It even looks like the original capacitor, and I think the negative side is the one with the stripe, but I'm not quite sure, so I'm gonna search for a datasheet for this. So, because I suck at managing time, it's been a couple of months since I looked at this last and I lost a bunch of footage, but I guess the video is getting long enough. And by now all the capacitors have been replaced. I think this turned out quite alright. And the original valves are back in there. And I've set the bias again. And we're connected directly to the mains, and I think there's not much left to do, but try it out with the guitar and see how it sounds. I checked the power level again after replacing the capacitors, and we're getting about 200 watts until it starts clipping, so either I keep overlooking something and I really cannot find it, I give up, or Fender is exaggerating the numbers. I may never know. And for testing, the output's gonna go into the attenuator and then into my pathetic little test speaker, and then you will be hearing what that microphone hears. sounds pretty good, and I did have a play with the knobs. This equalizer is a lot of fun. You can really have good control over the, how to say, the timbre of the sound, like. And there's also this switch. It says bass and guitar, and if you put it on bass, it kills the treble. For guitar it sucks, maybe for bass guitar it is interesting, I do not know. I'm not a musician. Well, not really anyway. And there's this distortion switch, which gives you like the same effect like you're using a distortion pedal with diodes. Yeah, you can get a fair amount of distortion without any of this. Just by overdriving the output, especially if we turn this equalizer up. That sounds a lot smoother to me than if you use this distortion thing. Maybe if you use both, it's yeah, that's quite fun. One thing I'm left to test is that little circuit board we disconnected earlier. I suspect it's a preamp for getting a bit more overdrive, but nothing to it but to try it right. So now I have that little circuit board wired back in, and it's indeed a preamp, but we get quite a lot of hum from it, especially for the amount of gain we're getting. So yeah, that's no good. I'm not gonna bother to wire up the microphone for that. I'll be throwing that out. So I have a new tripod thingy, which means you can see from above. It's probably all crooked, but yeah, I'll probably be forever lazy when making videos, so get used to it, I guess. Don't know if anyone actually cares if things are straight or not. If you do, this is not the channel for you. I have no idea how this is attached. I think there are two screws here, but they're underneath some bunch of glue. Yep. It's kind of nasty. They put screws right into the transformer. I bet you it's the same people who did this. Because they use the same silicone stuff. Maybe, right? No. Aha. Yep. It's probably not a good idea to put screws in a transformer, but they seem to have gotten away with it. Oh. I pulled off the label from that transformer because I'm trying to remove the glue. Yeah, I'll just leave this as is. Someone made this by hand. They did take some care in making a neat little thing. And probably quite long ago, judging from the parts. Alright, that's out. And before we put this back together, I have to have a look at my list. Yeah, and did check the preamp valves. Just to remind me I put the right ones in. I check the potentiometers. Also, I don't know if I showed it on camera. I checked if there's any microphonic parts by basically tapping everything. What else? Replacing that tag strip, replacing the capacitors, checking out the mastery board, checking the bias. That's all fine. So I think we are done. All back together, still working nicely. I'm calling it done. Thank you very much for watching and goodbye.